Okay, so let's begin. I mean, I was sent a couple of questions by the students as well. So what I'm going to do is first I'm going to go through these problems that I posted, and then so we can go through the problem. जो the students have problem post किया उसकी बात कर लेते हैं. So there's a question. So repeat the syllabus for this exam. So as I announced in the email sent last week, the exam is going to be from lectures 10 through 14. Okay, so lecture 10, I believe, was LTI systems, properties of LTI systems, and 11, 12, 13, 14 was from Fourier series. Okay. Acha. So this is a problem. This was actually from one of the exams a few years ago. And what you're required to do, so this is an objective type, right? So you're required to find A naught, right? Which is the DC value in the signal. So how do I do this? Kya kare? So who tried this? G. Abdullah.
So you'll find the average value over the period.
Yeah. So how do you do that? So kya answer aata hai aapka when you find the average value?
So 1/4.
1/4. Okay. Hamza?
Sir, I tried this using the analysis equation.
Okay.
It was a little bit a lengthy method, sir. अगर आप x of t, sir, you need to just find the DC value. तो sir, आपका k is equal to 0 हो जाता है for that very point.
Yeah.
Sir, then you just need to integrate over the function. ये जो आपको periodic function दिया वो just one period. तो sir, you can break it down into 4 different like functions from 0 to 4. और sir, आप हर function के ऊपर integrate करके you get a final value.
Okay. Hamza, if you start doing this now, I mean, that's a valid method, by the way. Lekin remember, this is an objective type problem, and this was worth 2 points. Okay.
Yes, sir.
Right. So let me check. 2 points there. Yeah, it was worth 2 points. So you need to find the easiest way of solving problems, right? So I look at Kiri, what you're saying is correct. So you say Kiri A naught is defined as 1/4, and then integral from 0 to 4 of what x of t is. Right? Now, one of the harder methods could be you just plug in कि यार एक जगह पे minus t है, एक जगह पे plus t है, और एक straight lines की equations ढूंढें और उनका area निकालते फिरें. But I mean, what you see is कि what this thing represents is just the area under the curve. Right, so all I need to do is, because the period is 4, right? So this is the period, right? And this is 1 period, right? So this is where I'm integrating. All I need to do is I need to compute this area under the curve. ये निकालना है मैंने बस. ठीक है? And I know it's triangles, it's squares. So I know the triangles area, I know the squares areas. ठीक है? And moreover, ये सब करने के बजाय, so there's a very, very nice, elegant way of doing it. You see, if I just compute the area under this thing here and this thing here, this add up to 0 because of symmetry. Is that clear to everybody? Right? This area here, right? This area here and this area here are negatives of each other. And they add up, and therefore they are 0. Take it, because there's one in the negative side, the other is on the positive side, it's exactly symmetric, right? So I don't need to really compute them in the first place, right? I just cancel them out. What I'm left with is this area, and this area is what? चलो वो भी compute करने की जरूरत नहीं है मुझे. And this area, right? जीतला.
So what happened to जो आपने ऊपर लिखा हुआ है इसमें e raised to power minus j के omega naught t को क्यों नहीं लिखा हुआ आपने a naught का ये?
Because k equals 0, right?
Okay, ठीक है. So it's just a equals 0 पे.
हाँ, so k equals 0. So this was e raised to power j k omega naught t. Yes, you're right. But this k was equal to 0. Therefore, this entire thing was equal to 1. ठीक है? So इसलिए the DC value is just the average value. right? As it says in the problem statement as well. Okay. Now, where was I? So this area here is half, and this area here is minus half, right? So this cancels as well. I mean, this goes away. Minus half plus half is 0. So that means all I am left with is this thing. ये जो बच गया. Right? And the area under this is equal to 1. Right? So therefore, this is equal to 1. And so there's the 1/4 as well. So therefore, this is the answer. Okay? So just by looking at it as an observation, and I mean, computing the area under the curve is just equal. In computing the integral is just computing the area under the curve. Okay? Which in this case is very, very simple because they're just straight lines. Right? Any questions about this before I go ahead? Okay. Talha, ये question है या was this from before? जी हमजा.
सर मैंने पूछना कि अब्दुल्ला ने कौन से तरीके से सॉल्व किया था? I joined a little late, तो वो भी एक तरीका था या फिर was it something different?
Maybe Abdullah can shed some light on that.
सर मुझे पता है कि जो डीसी वैल्यू होती है वो एवरेज होती है, तो अब किसी सिग्नल ग्राफ की एवरेज होती है एरिया डिवाइडेड बाय टोटल टाइम पीरियड नीचे.
Yeah.
तो वो यही बात होगी एक तरह से.
बिल्कुल. सो एरिया आपने किसका निकाला था?
सर मैंने एक ट्रायंगल, एक ट्रेपीजियम, दो ट्रायंगल तो एक ट्रेपीजियम से निकाला था.
Okay. Right. So that's a valid way of doing it. But the way I did it was I knew that there's some negative terms, there's some positive terms. So I'll make my life easy and see कि जो negative terms positive से cancel होती हैं उसको तो निकाल दो. I mean, you don't really need to compute them because they just cancel out. Right? And this blue and pink things are like that. I don't need to compute them in the first place because they just cancel. सिर्फ green compute करना है मैंने. ठीक है? अच्छा जी. Now here's the second part, right? So this is okay, now you have a signal which is the absolute of x of t, right? So the curve that you're given in the figure 1, there's another signal which is the absolute of x of t, right? So all negative things become positive, right? And positive stay positive. And you are required to say which one of the following are true. So there may be multiple answers to these. Okay. So कौन से आंसर हैं जी? ठीक. Scan the जी Abdullah.
So I think only B.
Okay. All right. So what about A? Let's say जी Hamza.
Oh, sir, I wanted to say that I think only D is correct. Same power.
Okay. Right. So it turns out that A cannot be correct because when you're taking the absolute value, the Fourier series coefficients do not remain the same in this case. And the first, the immediate counter to that is that the DC value is going to change. I mean, जो पहली चीजें cancel कर रहे थे हम, अब cancel नहीं होंगे. So DC A naught is going to change, and of course, then A is not true, right? So this is not true. X of t is a power signal. Yes, that's true because it's periodic, and the area under the one single period is finite, right? The square of that is finite. The area and the square of the signal is finite, and therefore this must be a power signal, right? So that's something we know from before. Absolute of x of t has the same DC values as x of t, just like I said. That's not true. That cannot be true because the negative things become positive, and the things that were canceling earlier we may not cancel, right? Absolute of x of t has the same power as x of t. So Hamza says that D is true as well. क्यों Hamza?
अच्छा सर, so how I looked at it कि मैंने इसका देखा था कि आप मतलब it was a guess as well, लेकिन क्योंकि मुझे पता A और C तो पक्का गलत है, अगर आप उसको दूसरे लेके जाओ तो एरिया अंडर ग्राफ तो सेम आ ही नहीं सकता. पावर सिग्नल वाला पॉइंट मैंने मिस कर दिया था सर. सेम पावर से मैंने इसको पार्सेबल से लिंक किया था कि अगर आप इसका स्क्वायर लो सर, अगर देखें यहाँ पे नेगेटिव टर्म्स हैं कुछ, अगर आप इसका मैग्नीट्यूड करके स्क्वायर लोगे सो इट विल बिकम द सेम थिंग एज अगर आप इसके एब्सोल्यूट वैल्यू का स्क्वायर ले रहे हो. ठीक है, तो दोनों बात सेम हो जाती है और एंड ओवर वन पीरियड द पावर वुड बी द सेम अगर हम पार्सेबल को अप्लाई करें. तो आई थॉट के वहां से आंसर आएगा.
So why parsable?
सर पार्सिबल क्योंकि सर दैट्स द थिंग दैट वी कैन रिलेट लाइक क्योंकि पावर की बात हो रही है और फोरियर सीरीज की प्रॉपर्टीज और पावर के अंदर से यही फॉर्मूला था जो मुझे मिल रहा था, सो आई अप्लाइड दैट.
Okay, so there's no need for parsibles here. अगर आपको मैं Fourier series ना भी बताया होता किसी चीज़ के बारे में कि Fourier series कोई चीज़ होती है, the result that you use is not really parsibles. Parsibles just says that the power in the time domain is equal to the summation of the absolute of the Fourier series coefficient squared, right? So that's what parsibles relationship tells you. I mean, here we're just required to find the power, and the power is equal to absolute of x of t squared dt, right? And that's the key here, as somebody said. Okay, if when you take the absolute value and you square it, so this is going to be the same as if you take the absolute of the signal and that's another signal, and then you take the absolute again and then square it. It doesn't matter, right? Because squaring in any case जो नेगेटिव वैल्यू को पॉजिटिव कर देता है, राइट? सो पहले एब्सोल्यूट ले लूँ और स्क्वायर ले लूँ या पहले स्क्वायर ले लूँ एब्सोल्यूट वैल्यू, डजंट मेक अ डिफरेंस, राइट? सो दिस इज आल्सो ट्रू. Okay, any questions about this problem? Okay, जी हमजा.
जी सर वो पार्सल वाली बात एक बार दोबारा रिपीट कर देंगे, आई डिडंट क्वाइट कैच इट.
या पार्सिबल्स, देखिए पार्सिबल क्या है? पार्सिबल सेज कि दिस इज पार्सिबल्स, right? So if somebody tells me okay, the key to getting this result is through the parsible's relationship, I mean, you don't need the parsible's relationship to get to that result. Okay, the question here is,
I can't see your board.
You can't see my board? Can everybody? I can see my board on the other screen.
Oh, sir, let me just check.
Yeah, so I usually run another meeting. So मेरे पास जो चीज आ रही है वो through the internet आ रही है, right? So
सर मेरे पास आपकी सर मेरे पास आपकी फोटो आ रही है एक वुमेन्स ब्लैक बोर्ड में.
इनकी होगी वैसे आ रही है, आई गेस. स्विच शेयर स्क्रीन पे स्विच कर लो.
स्विच टू शेयर स्क्रीन पर.
हो गया. I'm sorry, हो गया.
Okay. All right. So the point I was making was, okay, the parsible's relationship just relates the power in the time domain to the Fourier series coefficients. Right? That's what parsible tells you. This question is not about that. This question is, okay, this problem is, yeah, what is the power, right? So what you're just required to compute is this. ये निकालना है. इसका Fourier series के साथ कोई ताल्लुक नहीं है.
ठीक है सर, आई गेट इट.
Right? Okay. All right. So now this is another problem. All right. So what do you think about this? Right, so this is perhaps a little bit related to some of the content that we've done earlier as well. So I don't want to spend time on कि वो periodic है या नहीं है, क्यों है. So it turns out कि जी A and B are true. This is periodic and the frequency is omega naught by pi by 12. Any other thing that's true, and Hamza says D as well. Anybody else thinks D is correct? Usman Nadeem says A and B. What about D? So Abdullah says D is incorrect. Hamza, Hassan says D is true. Why do you think, Hamza, D is correct?
Sir, so basically I checked whether the signal is even or not. So after plugging some values, I found out that this is an odd signal. And sir, for an odd signal, the average value, like the DC component, is 0. So sir, at k is equal at a sub k, a sub 0, the value has to be 0. So answer third D is correct. Okay. If I'm interpreting the option correct.
Achha, so Hamza, so you need to get to the right result through the right concept. What you're saying is true. Lekin what if this was a cosine only? Right? That's not an odd signal, right? मैं आपको ये कह देता, right? So this is cosine pi t by 4 minus pi by 5, right? This is not an odd signal, right?
Yes, sir.
Then going by your logic, would it mean that a naught is not equal to 0?
Yes, sir. Jitna, yes, I think so.
So that would be an incorrect
मैंने
thing there, right?
ठीक है
So
सर, ठीक है सर.
as Mustafa says कि जी इस green signal जो मैंने ये क्या इसका भी a naught 0 है. A naught is 0 because there's no DC value here. Or in other words, if you compute the average value is going to turn out to be equal to 0 over one period. Okay? The other way to think about this is if you do the Fourier series decomposition for this, cosine is an exponential, right? Are two exponentials. One at plus pi by t, pi by 4, omega naught equals pi by 4, and the other one is omega naught equals minus pi by 4. And there's no a naught term, right? There's no constant term, right? That's another way to think about this. And similar is the case here. I mean, there's no constant here, right? And that's why D is correct as well. And you could, if you really wish, do a very, very quick Fourier series decomposition for this, and you will find that A naught turns out to be equal to 0. Right? Ji Talha?
So yeah, constant. What do you mean by constant here?
Constant जो है कोसाइंस के साथ जो है अगर यहाँ पे constant ही होता, right? But
for a DC value there should be this constant.
No, but not necessarily. I mean, that's what I was about to say. That's what I was about to say. That this is not the only way for the A naught to be equal to 0. In fact, I could come up with some hanky-panky here so that if you have a +2 here, that will make A naught be equal to 0. Okay? So that really depends what the signal looks like, what the average value of the signal looks like. Right?
So what is the best way to figure it out in
right? The best way to figure this out is do a quick Fourier series decomposition here. Okay? I mean, if you really want to go the complete route, right? Since it's objective type, so there's some things that you can use here very, very quickly, but you have to be really, really top of the game to be able to do this quickly. Okay? Like, if you feel you're not at that level yet, so you do a Fourier series decomposition for this. And when you do a Fourier series decomposition for this, you will find that A naught will indeed turn out to be equal to 0 because iske andar 4 exponentials aayenge. And that's clear, right? Right? This is going to be 1 upon 2j e raised to power something minus 1 upon 2j e raised to power something minus 2 times e raised to power something or you divide by 2 or phir minus 2 e raised to power something divide by 2, right? So this is just an Euler's identity expansion, right? And this term here and this term here and this term here and this term here will not be 0.
Yeah.
Right? If they're not zeros, iska matlab A naught to 0 ho gaya. Because for A naught to be non-zero, you would have had to have a term here in which this exponential raised to power something, that something should be 0. Okay? All right, so therefore D is true. And then there was an interesting question about what about option C?
Yeah, right? I was going to ask.
So the option C is the only non-zero Fourier coefficients of x of t are A plus 1 and A minus 1. Right? And the answer, how do I know how the answer to this is, how this is incorrect without really computing the exact Fourier series decomposition?
So we actually know that 4 terms hongi.
Exactly.
So those 4 terms will have actually 4 components. So like,
excellent. Right? So I know that there are going to be 4 terms. And so यहाँ पे C cannot be true without really evaluating what the Fourier series coefficients are.
Excuse me, sir, मुझे D समझ इसलिए नहीं आया because जो उसका k is equal to 0 पे A0 जो है हमें पता चल गया कि वो 0 है because like उसकी A0 वाली term नहीं है. सर पे how does D hold true? Like वो कह रहा है x of t has DC component k equal to 0. तो like वो नहीं है ना उसके पास.
Has 0 DC component. This means that A0 is equal to 0.
Oh, yeah.
That's what it means.
Okay. Oh, yeah, sir. I got it. I'm sorry.
Okay.
Yeah.
Hamza?
जी सर सर आई वांट टू आस्क कि आप बार बार ये कह रहे हैं कि you need to look at the average value. Sir, the average value is the area under graph for one time period for a particular signal.
Yeah, अभी जो हमने बात की थी, right? So the average value is the area under the graph, as Abdullah said as well, over one time period divided by the length of the period. ठीक है? And I know since a cosine and sine है, तो cosine की average value क्या होती है? That's another way to think about this. Over multiple of periods, cosine की value क्या होगी? हमजा?
जी सर मेरे से पूछते हैं सर जीरो सर.
Zero होती है, right? And what about the sine?
जी सर साइन की भी जीरो ही होती है.
आप इसको अगर इंटीग्रेट कर दें तो ये मुझे पता है ये भी जीरो आ जाएगा, ये भी जीरो आ जाएगा. तो that's
ये भी
another.
जीरो आ जाएगा.
You don't really need to then do the Fourier series decomposition.
ठीक हो गया सर.
ठीक है? अच्छा. So then there was this question, KG, is the exam going to have objective part 2? Maybe or maybe not. All right. Achha, so this is any other questions about this problem or part number 11? All right, so this is
सिर्फ so for part C का चेक करने के लिए we usually just check ये इसी तरह चेक करें कि E की कितनी पावर्स होंगी.
Yeah.
Like in this case, one of them would be e raised to power pi by 3 and negative pi by 3.
Yeah. और फिर pi by 4 है और एक minus pi by 4 है.
Yeah. So मैंने हमने इसी तरह चेक कर.
Yeah. ठीक है. So therefore, four non-zero terms.
Yeah, they would be equal to a like pi by 3 जो है जिस तरह e raised to pi minus pi by 3 है. That would be equivalent to a की like what would the value of k would be in this case?
हाँ, ये आप so I would urge you to try to do it on your own. ठीक है? इसमें वैसे एक अगला प्रॉब्लम आ रहा है इस बारे में. लेकिन here's a quick. So e raised to power 1/2 j is by j pi by 3 होगा ना? t, right? तो इसको I know that omega naught is pi by 12, right? So this is 1/2j e raised to power j pi by 12 times 4 times t, right? That's pi by 3.
Yeah.
ठीक है? So फिर क्या हुआ? This is omega naught and this is k. So this is what? This is A4. And you can do all of the rest. So there's a problem जो आपके बाद में आएगा इसी के इसी से related. ठीक है ताला? Yeah. Okay. So this is part 13. What do you think? So this is a sign, right? It appears a sign, okay? And the important thing to note, so sign है ना, right? Appears to be a sign. इसकी average value 0 होगी, right? या नहीं?
नहीं, इस केस में नहीं होनी चाहिए ना, because it's all positive. It's shifted on the y-axis.
Yes.
And it's all positive.
Excellent, right? So it cannot be 0. Because of the fact that ये जो है -7 है, it's shifted actually down on the y-axis. ठीक है, shifted down on the y-axis, right? So this cannot be true. A cannot be true, right? The DC component value is strictly greater than 0. So DC component is A0, right? So this is what that means is what this is E0 is greater than 0. Is that true? Okay.
Excuse me, sir.
जी then.
Excuse me, sir. सर मुझे समझ ये नहीं आ रहा है कि जब हम लोग जो ग्राफ बना होता है सर, उसमें जब हम लोग एरिया अंडर द ग्राफ निकालते हैं तो सर वो विद रिस्पेक्ट टू एक्स एक्सिस निकालते हैं. तो सर इसमें हमने जब ग्राफ को शिफ्ट कर दिया है तो लाइक हमने ग्राफ को नीचे शिफ्ट कर दिया, सो दिस इज एक्चुअली बिलो द एक्स एक्सिस इफ आई एम नॉट रॉन्ग. सर फिर उसमें हम कौन सा एरिया चेक कर रहे हैं, वो वाली बात मुझे समझ नहीं आ रही.
वो क्या आपके ख्याल में क्या करेंगे?
सर वो तो फिर
ये अगर y equals 0 है, y equals 0 के क्रॉस होता है ना हमेशा,
Yeah, sir. Yeah, sir.
राइट? सो दिस इज, और ये टर्म है ये.
So this should be the area between the y-axis and the. Oh. जी sir.
Is that कि जी यहाँ पे this is not y equals 0. Right, so don't be confused by that fact. Y equals 0 ऊपर पड़ा हुआ है कहीं पे.
जी sir.
ठीक है?
जी sir.
अच्छा जी. तो I was here कि y is b, is that true or not? अगर y equals 0 ऊपर पड़ा हुआ है. Right, so.
So I think this should be true.
No, this cannot be true. एरिया कहाँ पे कितना होगा? पॉजिटिव होगा, नेगेटिव होगा?
नेगेटिव होगा ना?
नेगेटिव होगा ना?
This cannot be.
Yes. This cannot be true.
Yes, sir.
So A naught is always negative. ठीक है? अच्छा. What about C? So there are some people who say that C is the answer, the only correct answer. कौन कह रहा था? ऊपर chat box में ऊपर रह गए सारे. Right, so Daniel was saying that it was C.
Yes, sir.
जी Daniel, क्या ख्याल है? क्यों नहीं है? C is true.
Sir, sin के दो होते हैं ना?
Yeah.
Exponentials, एक positive omega और एक मतलब.
Good.
और एक जो offset है A0.
Good, excellent. Right, so this is true. Right, because के जी sin के दो हैं. There is a plus omega naught and there is minus omega naught. And then since there is an offset here as well, so A naught would also be non-zero. So C is the answer. Right, and if C is the answer, of course, D cannot be the answer. Okay. Any questions here? Ji Hamza.
Sir, मैंने ये पूछना है कि how do we know that these three are the only non-zero spectral coefficients?
Because
और भी non-zero नहीं हो सकते.
नहीं, because it's a sinusoid, right?
So it will break down into two exponentials or.
Yeah, दो exponentials तो रही DC है.
उन exponentials के ऊपर जो k की वैल्यू होगी वो फिक्स ही होगी.
वो दो ही होगी ना, k equals +1 and k equals -1.
अच्छा ठीक हो गया सर. ठीक है.
Excuse me, sir.
जी Zen.
सर वो तो हमने एक दफा क्लास में भी साइन की भी है, हमने उसकी प्रोसेस की ट्रांसफॉर्मेशन की भी, सो वी नो दैट उसमें तीन होते हैं सर. सर अगर कोई और आ जाए, कोई और लेट्स से कोई और भी और फंक्शन आ जाता है, तो उसमें हम लोग दोबारा निकाल के पता चलेगा ना हमें, या उसके अलावा तो कोई हैक नहीं है?
Of course. वो अभी तक कुछ किया नहीं किया, because those are basic problems.
जी सर.
Right, so anyway. Okay. So is अच्छा जी. So here is also another problem from perhaps another midterm exam from a few years ago. पहला क्वेश्चन है कि जी, let's do part A first, right? So you're required to find the Fourier series coefficients for this signal. How do I go about this? Apply definition, right? Before I apply the definition, I need to know what the period for this is going to be, right? So let's try to sketch this out first, right? So if I have these two terms here, so let's say this is term A, right? And let's say this is term B, right? And let's sketch the term A and term B. So term A, so this is part A. Term A kya dikhti hai, right? So the term A are, so what would term A be? Series of deltas, so it's train of impulses, right? So there's a train of impulses. The first one is going to be at time t equals 0. The other one is going to be at time t equals 4. the next one is going to be at time t equals 8, and similarly at -4 and -8 and so on and so forth. So it's a periodic signal, right? And the height of all these impulses is 2. That means the area under them is equal to 2. Okay, is that clear to everyone? I mean, this is the signal A, right? And what about signal B? Signal B, if this is the time axis, right? Signal B, what type of signal B? What would signal B be? Anybody else? Hassan ke alawa? Okay, alternative signs. What about the period, Daniel? Period would be 2, excellent, right? So this is time 0, and 0 pay, you're going to have a positive impulse, and 2 pay, you're going to have negative impulse, and then a positive impulse, negative impulse, negative impulse, and positive impulse, and so on and so forth, right? And the separation is going to be 2 seconds, right? And the height for each and every one of them is going to be half, right? So this is half, and so on and so forth. Okay. So what would x of t be? So x of t is just going to be simply, you add them up, right? So x of t is the summation of A and B, signal A and signal B, right? And what you therefore get is x of t looks something like this. So this is t, or 0 पे क्या height होगी impulse की? At time t equals 0, right? There's going to be impulse which is 2.5. Excellent, right? So this is 2.5, right? And then at time t equals 2, this would be minus 0.5, and then at time t equals 4, this would be 2.5, and so on and so forth. So on and so forth, right? So this is time 0, this is 2, this is 4, this is 6, this is -2, -4, -6, and so on and so forth, right? So the period for this is what? Period is equal to 4. Excellent. Okay. Now, how do I compute the Fourier series coefficients? I mean, there are multiple ways I can do it. I can use the properties directly or some known results, right? But I would do instead, let's just apply the definition, right? So the definition is, the definition just tells me that the Fourier series coefficients, AKs, are equal to 1 upon t, which is 4, integral over 1 period, and which is x of t. And what period should I choose? Now here's in order to make my life easier, I can choose -1 all the way up to 3, right? So this is my integration period, because that covers the entire period, right? 4 to 0 नहीं होगा, 0 to 4 हो सकता है, right? 0 to 4, excellent, right? But if it's 0 to 4, you can do that, but then you may run into slight bit of an issue क्या वो 0 to 4 minus है या 4 plus है, so it must be 4 minus, right? So इसलिए in order not to run into those complications, I will just take from -1 to 3. Let's do that first, and then I can talk about this again, 0 to 4, right? So this is from -1 to 3, right? And this is x of t e raised to power minus j k omega naught t. What is omega naught, right? Omega naught is 2 pi by t, which is pi by 4, pi by 2. Okay, so this is pi by 2 t dt, right? What does this give me? This is 1 upon 4 minus 1 to 3, And within this 1 period minus 1 to 3, there is, I know there's a delta 2.5 delta t. And then there's a minus 0.5 delta t minus 2 times e raised to power minus j k pi by 2t times dt. So what does this evaluate to? I just use the sampling property of the delta function. So this is 2.5 multiplied by 1 by 4 and e raised to power j k pi by 2 times t jab 0 ho jayega, that goes away, right? And then this is going to be 1 by 8. So chalo, this is 0.5 multiplied by 1 by 4 times e raised to power minus j k and pi by 2 times 2, right? I just plug in t equals 2, right? This cancels and I get e raised by jk pi. What is e raised by jk pi?
1
1 तो नहीं है,
इसका -1 होगा,
-1 raised to power k. Okay, so this is 1 by 4 into 2.5 minus 0.5 times minus 1 raised to power k. Okay, and अगर मैं इसको थोड़ा सा और simplify करना चाहूँ, तो I could say, because this is related to one of the problems that the student asked me, right? So this is 1 by 4 times 2.5 minus 0.5 when k is even, and this is equal to 1 upon 4 2.5 plus 0.5 when k is odd. And which is equal to, this is equal to 2 and this is equal to 3, right? So 3 by 4 and this is a half. Okay, so fine conclusion is this is 1 by 2 when k is even, and this is 3 by 4 when k is odd. Right, जी हमजा.
सर मेरा ये एक सैम्पलिंग प्रॉपर्टी से सर एक सवाल था कि ये जो आपने पहले टर्म में वैल्यूएट किया 2.5 into 1/4, सर
Yeah.
इसके अंदर आपका एक्सपोनेंशियल टर्म क्यों नहीं है? अगर आप ये एक बार दोबारा बता दें.
Because it's delta t, right? Right, delta t times e raised to power j k pi bit क्या होता है? What is delta t times e raised to power j k pi by 2 times t? हमजा जी हाँ.
सर मुझे याद नहीं आ रहा इस वक्त. सैम्पलिंग प्रॉपर्टी से शायद उसको अलग कर देगा वो तो.
Yeah, so right, so this is delta t, right? This was pre-exam 1, right? So इसलिए even though the course has been divided into modules, this does not mean कि ये पहली सारी चीजें बिल्कुल भूल जाएं. वो implicitly utilize होती रहेंगी.
ठीक है सर.
ठीक है. जी हमजा राशिद.
सर जो आपने XFT को इंटीग्रल के अंदर लिखा है सर, ओरिजिनली ये t-4n था और t-2n था. तो मुझे ये नहीं समझ आ रही कि ये n वाली टर्म को किस तरह आपने हटाया है.
Okay, because देखें जो t minus between 0 and 3, right? t minus 4n or t minus 2n results in impulses precisely at either 0 or 2. That's it. Okay? Right? So the reason why I went about that sketching it first is so that we just get rid of that summation terms and just graphically look at what the signal looks like. Right? Graphically visualize what the signal looks like. And from there you integrate.
तो सर जो पीरियड वन पीरियड के अंदर जो टर्म्स होंगे सिर्फ उनको हम वैल्यूएट करेंगे.
Yeah, well, that's how you compute the Fourier series, right? The Fourier series is just evaluated over one period. And all of this graphical exercise just was try to find out कि जी एक period के अंदर क्या signal है, signal क्या दिखता है. Right? But if you're interested, तो I mean you say कि जी ये वाली term जो है ना वो पहली A की n equals 0 वाली term है और B की n equals 0 वाली term है. ये B की असल में n equals 1 वाली term है. And so on and so forth. So थोड़ा सा आपको और विजुअलाइजेशन करनी पड़ेगी कि यार ये क्या हो रहा है. ये A n equals 1 की टर्म है और B की n equals 2 की टर्म है. Right, but if it doesn't make sense, so that's fine. Let me just do it graphically. All right. Hamza, is that clear?
जी sir.
चलें. Right, so let me delete this. Okay, confusion now. Okay. Then there was this problem B, part B, right? Consider the LTI system with input x of t and output y of t given by, so this is the input, this is the output, right? And I know some things about h of j omega. I don't know what the, okay, right. So this is something I forgot, right? So Marine asked, how do you determine the limits? Right, so in this case, I determined the limits from -1 to 3, right? Now, remember, according to the definition, these limits could be anywhere over the over one period, right? So this could be from -1 to 3. It could be from -0.5 to +3.5 and wouldn't make a difference, right? It could also be, by the way, from, let's say, I could say here to here. इसके अंदर भी सिर्फ दो terms आएंगी, and I would encourage you to now go ahead and evaluate this from here to here and see कि उससे भी result यही आता है या नहीं आता, and you would get the same result because of the periodicity of the exponential. Okay. Now the only issue that's remaining is what happens if I choose these limits from 0 to 4, right? ये मैं 0 to 4 ले लेता हूँ, right? अब 0 to 4 के अंदर कितनी impulses आ रही हैं? That's where people may get confused, right? If I'm integrating from 0 to 4, so there's an impulse that I get here, there's an impulse that I get here, and I claim कि ये impulse नहीं आएगी उसके अंदर. So this is not three pulses, Hassan. So this is because in the integral, strictly speaking, is from 0 to 4 minus, right? Because you have to consider one period, right?
So shouldn't it be from 0 minus to 4 minus, या फिर 0 plus to 4 plus, दोनों में एक एक आ जाएंगे फिर.
Right. So right. So that's fine, right? So 0 minus to 4 minus. ठीक है? तो 4 वाली जो impulse है उसके अंदर शामिल नहीं होगी, क्योंकि 4 वाली impulse तो आप पहले असल में consider कर चुके हैं within the at the time t equals 0, right? So that's a slight bit of a nuance here. That's why I did not choose 0 to 4. Right? Mehreen, is that clear?
Yes.
Right. Now, at the same time, once again, I encourage you to do this on your own, which is what? Okay, try the limits from, let's say, minus 2.5 to 1.5 and see if you get the same result. And you will find out that you indeed get the same result. As you should verify that. ठीक है? अच्छा. So here's part B, right? Which is sort of related to the CEP exercise as well. So Marine asked me to do that. And hopefully इसके साथ ये clear हो जाना चाहिए, right? So now you have x of t as an input to a system, right? So there's this x of t, which is going as input to a system which has an impulse response h of t and frequency response h of j omega. And this system is LTI, of course. and the output turns out to be y of t. Okay, and I know what x of t is, and I know what y of t is, right? Given that these are the inputs and the outputs, what you are required to find is what h of j omega is for these values. Okay? How do we do this? What could be the first step? Anyone? Find the impulse response. That's the whole problem, Hassan. We don't know what the impulse response is. What we know is that the input is something, and we know what the output is something. From this input-output relationship, we need to determine some h of j omega, some values of h of j. Jeetala?
If we find h of t first, we can use it to find h of j omega. h of t हम find कर सकते हैं, वो जो relation था हमारे पास y of t equal to h of t integral of h of t into x of t minus t naught. Yeah, in this case we can go with x of t into h of t minus t वो tau. हम उससे h of t minus tau निकाल सकते हैं, and then we can find.
Okay. There's a much easier way.
So why not we convolve x of t with y of t first, and then we'll find h of t, और फिर उससे h of j omega निकाल लेंगे. If that makes sense.
लेकिन x of t convolved with y of t is not h of t. X of t convolved with h of t is y of t.
इससे जो हमने ब्लॉक डायग्राम पढ़ी थी सर, उसमें हमने कहा था कि सर अगर x of t h of t से कन्वॉल्व हो रहा है और फिर y of t आता है, so if अगर हम लोग h of t को x of t से कन्वॉल्व करेंगे तो फिर भी y of t आ जाए. Oh yeah, सही है.
So y of t तो नहीं, so y of t is always on the left hand side, right? So,
yes, sir,
you need some sort of an inversion here, as Mustafa says as well, and इससे पहले Daniel said as well कि जी you compute the x of j omega, you compute the y of j omega, then simply divide. Daniel, how do you do that? How do you know what the division करनी है? We've not done that yet, वैसे. We've not covered that yet.
Sir, वो circuit से याद है मुझे.
Okay. Even if you do that, you're going to run into problems because then you would have some divisions by 0. Right? That may or may not be possible. And once again, x of j omega, sin का x of j omega करेंगे, तो deltas आ जाएंगे. How do you divide a delta by a delta? That becomes also a problem. Okay. So what you use here is that lecture on Fourier series and LTI systems, and the fact that यहाँ पे जो दिया भी हुआ है, so hint is given to you, right? Use the fact that the signal a used by j omega t is an eigenfunction of LTI system with the corresponding eigenvalue equal to h of j omega. Right? This is what we know of, and this is something we're going to use. Okay, so let me solve this here. Right. So x of t, I just apply the Euler's identity here. So this is 15 by 2j e raised to power j 10 pi t minus 15 by 2j e raised to power minus j 10 pi t plus 5 by 2 e raised to power j 30 pi t minus 5 by 2 e raised to power minus j 30 pi t. Okay, and if this is the input to an LTI system, what would be the output of the LTI system?
Sir, fourth term से plus नहीं देगा?
Yes, thank you. Right, so let me use some more space here. So what would y of t be? I mean, forget about what y of t is, or what desired y of t is. I mean, let's just say if this x of t is input to an LTI system, can I quickly determine what the output is if I knew what h of j omega was? And I use the fact that these exponentials are eigenfunctions. So this is equal to 15 divided by 2j e raised to power j 10 pi t times h of j omega, and where this omega is 10 pi minus 15 by 2j e raised to power minus j 10 pi t, and this is h of minus j 10 pi plus 5 by 2 e raised to power j 30 pi t times h of j 30 pi and plus 5 by 2 e raised to power minus j 30 pi t times h of minus j 30 pi. Okay. Right. And what result have I used? The result that I've used is e raised to power st as an input to an LTI system that results in an output which is e raised to power st times h of s, right? Something we've done, right? So that means e raised to power j k omega naught t is going to result in e raised to power j k omega naught t times of h of j k omega naught. This is exactly what I've done, and I apply linearity of the LTI system. Okay. Achha, if this is the output, my desired output is what? Is y of t, yeah, chale y desired kar dete hain, is equal to what was given? 20 cosine ten pi t. Right? So, फिर क्या करें?
Can you show the question again?
Right. So show okay. So the question is, Keji, this is your desired output. Okay. Right. So this is your desired output y of t. Right. You need to find this h of j omega for these values plus 10 pi, minus 10 pi, 30 pi, and minus 30 pi. In सब के लिए निकालना है so that the output becomes y of t equals 20 cosine 10 pi t. Right. So let me come back here and ask the question. So, and let me expand this a little bit, which is this desired y of t is 20 e raised to power j 10 pi t divided by 2 and plus 20 e raised to power minus j 10 pi t divided by 2. Just a simple Euler's identity, right? And let's say this is 1 and this is 2. And here is the question for you. How should one, yeah, chale, for what values of h of j 10 pi, h of minus j 10 pi, h of j 30 pi, and h of minus j 30 pi is 1 equals 2. Okay, so you just compare the coefficients, as people say, right? So what would be the answer? I just need to compare 1 with 2 and compare the coefficients. Right, so people other than who have spoken in the chat box, what do you think? What do you think these values should be? Tell me, Marine, because you asked this question as well. What do you think these values should be?
I guess 0, since we don't have e to the power 30 pi jt in the
Excellent, right?
Output.
Excellent. So they must be 0. And this must be 0 as well. Because that's the only way you will not have an exponential term which is raised by j, a periodic exponential of a frequency 30 pi. You want all of them to be nulled out. And the way to null it out is to ensure that the frequency response, which is h of j omega, evaluated at omega equals 30 pi is equal to 0. Okay, that's the only way to do that. right? That's the only way to do that, right? So therefore, this is equal to 0. That's the answer. And this is equal to 0. Now, what about the other terms? Right? So you need to compare this thing here with this thing here. You get it?
4/3 and -4/3.
Right? So you just compare the two, right? So like a J bhi aayega na?
Oh yes.
Right? So you just need to ensure that in order to find this, you say that 15 divided by 2j must be equal to 20 divided by 2. Right? So, sorry, what am I missing? Times each of j 10 pi. Right? And this 2 cancels with this 2, right? And this implies that h of j 10 pi must be equal to, so it's 20 divided by 15, but which is 4/3, and therefore this is 4/3j. So there's a j term here as well. 4j/3. Excellent, Asad. Okay. What about the other term? इसको निकालने के लिए I need to ensure that h of minus j 10 pi times 15 divided by 2j with a minus sign must be equal to 20 divided by 2, and therefore this turns out to be h of j 10 pi must be equal to minus 4/3j. Just a negative sign. And that's the solution. Right? Is that clear? Any questions about this before I go ahead?
Negative किस तरह है? Why did you write a negative over there?
Because ये negative था ना?
Oh, minus j 10 by pi है, लेकिन अपने वो उसके बाहर किस तरह ये क्या है?
Because yeah, you see, I mean, ये जो पूरी negative term थी, ये पूरी negative term थी, ये positive term हो जानी चाहिए. Right, Tala? Is that clear?
Yeah, ठीक है sir.
Okay. अच्छा जी. और कोई question? Okay. Let's see, और क्या? All right. So this is, I believe, perhaps from one of the quizzes a while ago, or perhaps from a midterm exam. I forget. Okay. So अब इसमें है कि जी, and this is related to the objective type as well, कि जी जिसमें you were required to compute you're not required to compute the Fourier series coefficients, लेकिन उसके inferences उसी ऊपर थी. So let's do this quickly. Or so what I can do instead is कि let me, जो students ने मुझसे specifically answers मांगे थे. Right. So Mehreen asked me कि जी DC to AC conversion करनी है, right? And I will quickly give you a hint here and not go in a lot of details. Okay, if there's a square wave, right? So there's a square wave that's given to you. All right. And which is of a certain, so let's say if this is year 0n. If this is 0 axis, right? And which has a certain period, which is equal to t, right? And this is x of t. If you want to extract a sinusoid of the same frequency out of the square wave through an LTI system, what can we do? So this x of t goes in to an LTI system which has an impulse response h of t and a frequency response h of j omega. And my desired output here, let's say, is equal to some a times cosine omega naught t. Right? So how should I design this h of j omega so that for this x of t is, which is a square wave as the input, my output becomes a cosine, right? And I follow exactly the same ideas that I talked about this in the previous example here, previous problem, which is I know that the desired is a by 2 e raised to power j omega naught t plus a by 2 e raised to power minus j omega naught t, right? And my x of t is actually equal to this ak e raised to power j k omega naught t, and this k goes from minus infinity to plus infinity, where the ak's we know of. I mean, we've done that through those examples, the examples problem that we've solved, right? And y of t is simply going to be equal to summation k equals minus infinity to plus infinity, and this is a k h of j k omega naught times e raised to power j k omega naught t. ठीक है? तो अब Marine, how should I choose h of j k omega naught or design in such a manner?
Sir, I'm not sure.
So if I want to ensure that your yd of t becomes equal to this, I just exactly do what we did earlier, right? Which was compare coefficients, right? And perhaps, I mean, people have trouble understanding really कि यार इस summation का क्या मतलब है? Right? What does this summation mean, right? Okay, so you see yd of t may, there's only one term corresponding to e raised to power plus j omega naught t, and there's one term corresponding to the term e raised to power minus j omega naught t, and all other k omega naughts, all of those terms must be 0. Okay? That means this must mean that h of j k omega naught must be equal to 0 for all k's except except k equals plus minus 1. Right? I need to filter out all of the other harmonics, right, which reside at 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught, all of those. I just need to filter them out or cancel them out or null them out, right? And this is a way of nulling it out by choosing the frequency response of the system or designing the system to ensure that the frequency response at these values of k omega naught turn out to be equal to 0 for all k. Okay? And I can choose e raised by j plus omega naught must be equal to, that must be I'm skipping a step here. So a divided by 2 times a1, right? And h of minus j omega naught must be equal to a divided by 2 a minus 1, right? And that would ensure that you get a sinusoid out of it. Now these systems are practically very, very hard to design कि जो ये ideal condition को satisfy करते हैं, and we typically use more realistic systems which are not that ideal, and that creates harmonics, that creates distortions, as you would see in your CEP. Okay? Any questions about this problem number 5? Right? Is this clear?
आपने equal किस तरह की, like how have you found it a over 2 a1?
Sorry, फिर से कहेंगे? चला
ये A1 कहाँ से आया इसमें, जब HJ ओमेगा इक्वल टू A2 A1 कहाँ से आया?
मैंने इनको कंपेयर किया ना, देखिए मैंने ये देखी इक्वेशन, ठीक है, और ये इक्वेशन देखी, और इन दोनों को मैंने कंपेयर किया, राइट, एंड आई सी के जी बाकी सारी टर्म्स मैंने जीरो करनी है, लेकिन जो k इक्वल्स 1 टर्म है ना, वो A1 H ऑफ J ओमेगा नॉट मस्ट बी इक्वल टू A/2, राइट, इसके बराबर होनी चाहिए वो,
ठीक है, सो वो A1 वहाँ जा रहा है,
वहाँ से गया, so J omega naught is actually E/2A1, and you can get the same thing for A minus 1. ठीक है, just comparing. Okay. Then, so let me skip this as well. So this was also a question that one of the students asked me. And part A is actually something that I've introduced myself because that may be useful for part B, and is actually related to one of the problems that we've done already, right? So if x of t is equal to this train of impulses, right? So this is t, and this is an impulse here at 0. This is an impulse at t. There's an impulse at 2t, and so on and so forth. Minus t and minus 2t, and the heights are 1. So then what are AKs? AKs are just simply 1 upon t, integral from minus t by 2 to plus t by 2. And this is a solved example in the book, by the way, right? And this is, I'm just integrating from here to here, and there's only one impulse here. So there would be delta of t e to the minus j k omega naught t dt, and this is just equal to 1 upon t. Okay? And all the Fourier series coefficients are the same, right? So all the Fourier series coefficients are constants. This is equal to 1 upon t, right? So that's part A. Now part B says, let's say there is a signal which is x of t, and that is periodic with a period of capital T equals 4, and the Fourier series coefficients are given by this expression here. This is this expression AK, which is equal to 1 for k is even values and is equal to 2 for odd values. ठीक है, x of t निकालना है, क्या करें? Any ideas? So this could, let's say this is in the exam tomorrow.
सर आप एक बार सवाल रिपीट कर दें कि मेरा इंटरनेट लैग कर रहा था।
राइट, तो ये लिखा हुआ सामने, राइट?
तो फार्मूला क्यों लगा रहे हैं हम लोग, लाइक वो जो x of t वाला सिंथेसिस इक्वेशन वाला फार्मूला?
Okay, you're going to run into problems there, right? So if you just use the synthesis equation, you're going to get an infinite sum, right? And that doesn't actually converge. Right? It's just like if this is true, AK equals 1 upon t, then that means that x of t is equal to summation AK e raised to power j k omega naught t, right? And this is equal to 1 upon t summation k equals minus infinity to plus infinity e raised to power j k omega naught t. This is a problematic sum because it does not converge. And using this Fourier analysis, what we actually know, Fourier series analysis, this turns out to be equal to this summation. K equals minus infinity to plus infinity, or rather n, let's use that, minus infinity to plus infinity. This is a train of impulses. Right? So I would rather use this result that I just derived, which is what result? Which is the result k, yeah, this summation n equals minus infinity to plus infinity, delta t minus n t. This results in Fourier series coefficients, which are always equal to 1, right? But what we're given is this is something for odd values and something else for even values, which we actually saw for one of the problems that we अपने solve किया था. Even values कुछ और आते हैं odd values भी कुछ और आते हैं, so it must be some, as Hassan actually points out, 2 delta function series. Okay, so here's how I am going to do this. I mean, there might be other ways of doing it. So let me write this here. Given क्या है? Given है कि capital T equals 4 and AK is equal to 1 for even values of K and 2 for odd values of K. All right. इसको मैं लिखूं कैसे? इसको मैं ऐसा लिख सकता हूँ, right? So this is equal to 1 plus 1 minus 1 raised to power K divided by 2. Right? Is that clear to everyone?
No, sir.
Right, so minus 1 raised to power K. So this is a trick that I use. Right, if I were to do this, this is how I would do it. K, अगर मैं आपको सिर्फ ये दे दूं, चलें, ये किसके बराबर होता है? Zen?
जी सर.
ये किसके बराबर है जो what you see on the screen? 1 minus 1 raised to power K divided by 2.
सर जो -1 की पावर K है that actually shows कि वो even है या odd, even और odd के लिए ना, तो अगर तो we take K as even तो वो 0 हो जाएगा और odd के लिए जो है वो like एक मिनट odd के लिए वो -1 वो 1 हो जाएगा.
Excellent, right? So this would be so this thing here is equal to
1/2
नहीं,
1/2 नहीं 1/2 नहीं 2 होगा
2 divided by 2 है ना, that's 1, right? So this is 0 for when K is even and is equal to 1 when K is odd. Right?
Yes, sir.
Right, so if I were to plot this out, so this is, if this is the K axis, right? ये even values पे 0 है और odd values पे 1 हो रहा है.
सही.
Right, this is
मगर हमें तो odd values पे 2 चाहिए ना.
हाँ, तो अब इसको मैं किस तरह मॉडिफाई करूं कि ये even values पे 1 हो जाए और odd values पे 2 हो जाए?
plus 1 कर देंगे.
Right, so I just add all ones. And that would give me AK, right? So so therefore this implies that AK is actually equal to 1 plus 1 minus -1 raised to power K divided by 2. Right? Good. So lots of people just say add 1, right? And therefore this becomes equal to 2 if I modify it. So this is 3, actually this is 1.5 minus half times -1 raised to power K. Okay. Right, so I mean, in an exam, I would probably not assign this kind of a problem, unless ये homework में कुछ इस तरह का कुछ हो चुका होता. Right, so the way I would pick this is that if there was a related problem in the homework, then this would be a fair thing to ask in the exam. Otherwise, not. ठीक है, इसलिए थोड़ा सा सुकून हो जाए. Right, but this is at the end of the chapter, by the way. This is from the textbook. It's from a textbook, which actually one of your colleagues sent me कि ये मुझसे नहीं हो रहा. And how many of you have actually done all of the problems? Right, so, and that's not unrealistic. I in the past, I know many students who used to come to me and said कि I've solved all of these problems. इनमें से सिर्फ ये नहीं हो रहा, ये नहीं हो रहा, ये नहीं हो रहा, ये मुझे बता दें. Okay, so that's an ideal that we, but also I'm drifting here. So here AK equals 1.5 minus half times minus 1 raised to power k. What's the Fourier? What's the time domain signal now? Do we have enough information to determine the time domain signal, right? So I would further modify this and they say this is half and this is e raised to power j k
pi k.
pi. Okay? And this is equal to 1.5 minus half e raised to power minus j k pi by 2 times 2. And the reason why I'm doing this is because this is omega naught, right? I want to bring this into a form which is e raised to power minus j omega naught t naught, right? Remember the shifting property of Fourier series. Now that's fair game. Okay, so I could have, for example, in the exam, I could have just given you this statement here, yay, and then I asked you to determine the x of t. That would have been fair game. Okay, G Roshin.
Sir, why did you multiply pi by 2 with 2?
Right. So the reason is because, I mean, for this particular problem, t equals 4, right? And omega naught, therefore, is pi by 2, right? So now I want to use the shifting property of the Fourier series, like time shifting property, which is if x of t results in a Fourier series coefficients ak, what about x of t minus t naught? That results in a Fourier series coefficient which are ak times e raised to power minus j k omega naught times t naught. So I'm just trying to bring this into that form.
Okay, sir.
Right.
Thanks.
So therefore I know, okay, this is t naught. This is t naught equals 2. Right? Achha.
Yes, sir.
Can you now guess what the signal should be? What the signal should be? And I use properties here, right? So if AK was equal to 1.5, इसका inverse Fourier निकालूं मैं तो क्या निकलेगा? चलो I can say this, yeah. If this is delta t minus 4 n going from minus infinity to plus infinity, the Fourier series coefficients for those are 1 by 4. That's something we've done in part A. Nahi, Abdullah, that's DC signal 1.5 means that the A naught is equal to 1.5. But what we have here, that in AK equals 1.5 for all Ks. Okay, so this is AK equals 1 by 4 for all K. Right? So, अगर ये AK 1.5 है तो फिर it's just linearity, right? So that means summation, I just need to multiply it with some constant so that AK equals 1 by 4 times 4. Okay, sorry. I just need to make it 1.5, right? Right. So I multiplied by 4 and I multiplied by 1.5. Right. So this would be 1.5 multiplied by 4, which is equal to 1.5. Right. So my conclusion, therefore, is that 6 times summation n delta t minus 4n, the Fourier series coefficients for that, so it says is AK equals 1.5. All right. But what about this term here? Now just take a look at this. Okay. And summation delta t minus 4n, I know the Fourier series coefficients are 1 by 4. I want to make it minus half. So minus 8 से अगर मैं multiply कर दूं, so then this would be minus half. Oh, minus half करना है? Sorry. Just 2 से multiply करना. Right? And if I just multiply here with e raised to power minus j k pi by 2 times 2, so this must be 2 here. Right? So I know I'm skipping steps. X of t is what you're looking for is this. So here's your result. I mean, in all fairness, I mean, if this was in an exam, I would probably go the other way. I mean, I would give you X of t and ask you to determine AK. But since a student asked me, so I had to do this. Okay, so this is the answer. Ji Hamza.
Sir, do we have to restrict to this a की specific delta function t minus 4n के about ही आपने किया है, मतलब कोई restriction लगाई थी question ने यहाँ पे?
हाँ, period 4 था ना?
अच्छा ठीक है सर.
Period 4 था. जी अब्दुल्ला.
So you've used this fact कि जब भी a के constant होंगे तो time domain में signal delta होएगा?
Yes, train of impulses. That's a fact.
Okay, और n का coefficient होएगा time period जो होता है वो.
Exactly.
इसको इस तरह देख सकते हैं.
Exactly. चलिए जी, there's जी तलहा.
ये जो ये डेल्टा t minus 4 and minus 2 कैसे क्या किया आपने?
Time shifting property यूज किया मैंने.
ये वाला पार्ट आप दोबारा एक्सप्लेन कर देंगे. माइनस ये इक्वेशन कैसे है? ये minus 2 सिग्मा डेल्टा t minus 4 and minus 2 वही.
Okay, so ये देखें, अगर ये था तो ये नहीं होगा. ठीक है? Right, if this implies that minus 2 delta t minus 2 minus 4n, इसका Fourier सीरीज क्या होगी? जी तलहा.
एक्चुअली ये आप किस तरह लिख रहे हैं -2 यानी?
I'm just asking if I were to shift in time domain. If I were to shift in time domain, the periodic signal I can shift in time domain, right? If I shift that periodic signal in time domain, what happens to the Fourier series coefficients? ये t naught कर लेते हैं, right? So then this is just equal to ak times e raised to power minus j k
naught
t naught. That's a property, right?
Yeah.
Right? If t naught was 2 and omega naught was pi by 2, so this would be pi by 2 times 2. Okay. So that's the fact that I've used, the properties that I've used.
Okay, so E2 is -1 by 2 or so.
Yeah. All right. So I know it's 7:30 already. So there are a couple of questions left. I mean, they're pretty straightforward. I think I'll let you do them on your own. Yeah, so problem 3, so let me leave this off as an exercise. If your problem solving is, let me know through Slack, so I'll try to answer. Okay, I have office hours tomorrow as well, by the way. Okay, true deltas represent them. So what do you mean by finite Fourier series, Hassan?
So जैसे इस केस में हमारे पास एक DC term थी and we had one other term in the exponential, right? So for example, if I had a sine cosine function, the sine में हमें पता है कि हमारे पास 2 exponentials आते हैं.
Yeah.
We could in principle then use the delta functions.
No.
और इसकी time shifting को.
नहीं Hassan देखें इसमें here there are not, so there are infinitely many non-zero Fourier series coefficients in this case.
Oh, okay.
Right, K भी है ना, so the magnitude never goes away, right? So this is actually minus half. Right, so the magnitude of all Fourier series coefficients is equal to half for all k from minus infinity to plus infinity. So the power in the signal is infinity, if you really think about it. So the average power is infinity, and so not a power signal, even though it's periodic. So that double E senior who was talking to you, उसको ये example आप दे सकते हैं जाके.
Oh, he just left.
He just left. All right.